Real quick, before you start working on the homework for 5.3, we need to talk about the instructions and the things that you're going to be instructed to do for these problems. There is a difference, you see, between solving in an interval versus just the plain solve. So here is a table that'll help you out, maybe. If the instructions say to solve, they're telling you that you need to answer in radians. And in fact, you notice here, if it says solve in the interval 0 to 2 pi, in fact, this should be rounded here, solve in the interval 0 to 2 pi, they're saying that this needs to be radians. The only time you'll answer in degrees is if they specify that it needs to be in degrees. Now, why this solve in the interval versus just plain solve? Why don't they always just say that? Well, the problem comes if we get something like this. Let's talk about maybe sine of x is equal to 1/2. Let's say that that was an equation I was solving for x. What I know in this problem is that I'm looking for two separate answers, right? I'm going to do all students take classes. I know that sine values in the first quadrant return positive values, and all students, that means second quadrant, this also returns positive values. Opposite of 1, hypotenuse of 2. Opposite of 1, hypotenuse of 2. Now, we've been doing these problems long enough, we understand that's probably a 30, 60, 90 triangle. And in fact, it turns out that the angle in here is 30 degrees. So I have two solutions, two separate values I could put in for x. I could say it's 30 degrees because we always start measuring from this positive x-axis, right? Or I could say I go all the way around here. This is actually 180 minus 30. That's actually 150 degrees. So there's two different answers. Now if it just said solve, then my two answers would be 30 and 150, but it would be in radians. So x would be equal to pi over 6 and 5 pi over 6, right? 5 times 30 gives me 150, 5 pi over 6. Now we run across the real issue. And when I do this problem, I want you to understand that my calculator, when I do this, is in degrees, right? If I come out of here and I type in the sine of 30, I get 1/2 like expected. If I type the sine of 150, I get 1/2 as expected. But how do I know that I'm not really talking about me going and doing a full rotation and then another 30 degrees? How do I know it's not 390 degrees, 360 plus another 30? Because if I type in on my calculator the sine of 390 degrees, I get a positive 1/2. How do I know that I didn't go, and we'll concentrate on this one for a second, how do I know I didn't go 2 full rotations? That's 720 degrees and then another 30. Because the sine of 750, 720 plus another 30 is positive 1/2. How do I know that I didn't go 1,000 rotations? Let's see, so 1,000 rotations, that's 360 times 1, 2, 3, 1,000 degrees, okay? How do I know I didn't go 1,000 rotations plus another 30 degrees at the end? Because if I type this in on my calculator, the sine of 360,030, that's 1,000 rotations plus 30 extra degrees is 1/2. You see, there's an infinite number of solutions here because we can rotate more than once. We can even rotate in the negative direction if we wanted to. How do we say that it can be an infinite number of answers? We get two choices. We can either spend the rest of our life answering this single math problem by continuing to write out all of the possible solutions individually, or we can learn the shorthand way. And I think that's probably the route to go, right? How do we say that 360,030 degrees is a possible answer? Well, here's what we do. I look at this picture and I notice that this 30-degree answer is the simplest answer, but every 360 degrees I repeat the answer, don't I? So I can state this, and this is in degrees, so I'm not done yet, but I could state this as I have 30 degrees plus some multiple of 360 degrees. N here is going to stand for a whole number, 0, 1, 2, 3. And really this tells me how many rotations I'm going around. That's what that section tells me. How many rotations am I going first before I add the 30 degrees onto the end? If I want to do this in radians, which is the real way, I'm going to say x is pi over 6 then, plus some multiple of 2 pi. And this is one of my solutions. And then I go and I say, well, you know what, the 150 degrees, it's going to do the same thing. Every 150 degrees, I'm going to start there, and every 360 after that, I'm going to repeat an answer. So I can say my other solution is x can be 5 pi over 6, that's 150 degrees, plus every multiple of 2 pi thereafter. And this is my shorthand way of saying that I can have an infinite number of answers depending on how many times I rotate first. And typically you're going to see 2n pi. That's going to be the most common one because we're talking every 360 degrees it repeats itself. Now if that makes sense, what we just discussed, what this answer is an answer for the solve instructions. You're not going to limit your answers. The nice thing is this, if they tell you to solve in the interval 0 to 2 pi, that means you're going to limit your answers to 0 to 360 degrees, right? Because that's really what 2 pi is. 0 to 2 pi means that we got none of this funny business going on the end. So if this problem said solve from 0 to 2 pi, you would tell me just pi over 6 and 5 pi over 6. You're only going to give the simple answers, none of the n pi stuff. If it said to solve between in the interval 0 to 360 degrees, it's even easier because our two answers there would be 30 degrees and 150 degrees. So our answers are only allowed to be between 0 and 360. Now if that makes sense, then you're ready to start the homework.